9.4, arithmetic series. Sequence is when we're going to actually find the formula and figure out what terms everything is. Series is when we have the sum. So right here, the sum of the terms. Finite series means we actually have a stopping point. Infinite continues without end. So when we're doing this right here, this formula is what we're concentrating on when we're looking for the sum. So first, find the sum of arithmetic series from 2 to 100. Now, that means my first, one thing I have to be careful with, this is even. So my first term would be a to the first is equal to 2. And my 50th term, not my 100th term, my 50th term would be 100. Why is that? Well, because I'm looking for the first one, or first terms from 2 to 100 that are even, not all of the terms. So when I use that formula, the S is saying to the 50 terms, and we know that we have 50 numbers because of this right here. 50 numbers, that's what N stands for. Divide by 2, so looking at that formula that's right above, and then it's your first term plus your second term. So if you plug that into your calculator, you get the first 50 terms would be 2,550. The next one, it's saying what is the sum of the finite arithmetic series. So my first term is going to be 4. My last term will be 99, except that I don't know which term that will be. So I have to figure that out. So if I look here, I'm adding 5 each time. So my D, my difference, this is now where we go back to sequences, sorry. So my last term is 99. And again, this is the other formula for a sequence. And we know that we're adding, or my first term is 4 plus, we don't know what term it is, but subtract that by 1. I know that my difference would be 5. So I'm going to figure out what term 99 is. So I have 99, and I have 4 plus, this would be 5n minus 5. So 99 is equal to 5n minus 1. Add the 1, 5n. That means n is equal to 20. So my 20th term is equal to 99. I need to know this in order to figure out my sum. So I'm going to go do my sum right over here. So that other formula, we have S and the 20th term, so the sum of the 20th term, there's n is 20, divide by 2, and it's your first plus your last term. Another way that you could write this is in sum notation. Now when I'm writing this in sum notation, this right here means sum. Whatever you're starting with, your first term would be here. I'm going to 20 terms, so that's going to be on top. And my actual equation, which we found out right here, this is the finite equation, 5n minus 1. That's sum notation right there. I jumped ahead a little bit. So my sequence is going to be 1,030. So if I add up all those first 20 numbers, 1,030, and then my sum notation would be this right here. So I want you to do C and D by yourself. So finding the sum in a series. So a couple of things here. I am looking at this sum notation first. Actually, I'm going to zoom in. So looking at this first one, I'm looking at sum notation. You have to be careful about using that formula that I gave you because you have to make sure that it's in the arithmetic series before you can use that equation. So this one is because it is one-dimensional. It's linear. We have the same thing as y equals mx plus b, that's the same thing. So we can use that sum notation. So we have the first 70 terms would be equal to my first term, a to the 1. If I plug 1 into my equation, I get 8 out. If I plug 70 into my equation, this is one's not as easy to do in my head, 353. So we have your first or your last term divide by 2. How many terms? So that'd be 70 divided by 2. And then we have your first term, 8. That's an 8. Plus 353. So this would be equal to 12,635 if you were to add up the first 70 terms of that equation. Second one, So when I'm looking at this is not arithmetic. This is not arithmetic. This is actually geometric. So what I have to do is actually figure out what the first 7 terms are and then add them all together. So if I put, I'm going to go 1, 2, 3, 4, 5, 6, 7. So if I plug 1 into my equation, I would get 1 minus 1 is 0 squared would be 0. If I plug 2 into my equation, I get 1 squared, which is 1. Plug 3 in, 3 minus 1 is 2, 2 squared is 4. Does anybody see the pattern here? So if I have 4 into my equation, I get 9. If I square, that would be 16, 25. If I plug 7 in, I would get 36. So now I actually have to add those all together, and I would get 9 to 1. That's sum notations 9 to 1. I want you to do C and D by yourself, and then you're done. Have a great, grand, wonderful time of your life right now.